Hello, my name is Veronica, a student at James Rwanda. Today I'll be taking you through on my assignment for statistical machine learning. The first part of the assignment, we are given the DNA microarrays dataset. So one thing we notice about this dataset, it has a very large number of variables and a lower number of observation at 79. So this presents a cost dimensionality. And checking on distribution of the response, we can see its balance. So into analysis, given that we have a large number of variables, we cannot create any models from this. So what we need to do is to select some of the variables that are significant to our analysis. So from this, we are using the Cross-Wallis test to help us identify some of the powerful predictors that we have in the data. So in our assignment, we've been given that to select the top 9. So after doing the Cross-Wallis test, Kruskal-Wallis test, we also check on the performance of the top 9 predictors using a box plot. And box plots help us to understand or rather see how each of the variables can distinguish between no cancer cases and cancer cases from our data to help us when we are modeling. So from here, this is the box plot of how the top 9 predictors are behaving. Generally, also for us to create our model, and so in this task, we first started with the classification tree. And from the classification tree, we noticed that the variable x201 to 90 was selected. So that is what the tree model preferred. But if you look from the Kruskal-Wallis test, this one model was not our best, but it was amongst top 4. So ideally, in reality, sometimes we might have choose your data as your top predictors as a statistician, but might not be the most important variable when it comes to modeling. So that we can learn that from tree classification tree, since it picks the predictor that gives the best or rather give the highest pruning when doing a model. So generally, that is what we looked in. We also checked on the correlation. Given that our dimension is really big for the input space, there's a high probability that you may encounter collinearity of the predictors. And from this plot, we just did the top 9, and we can see there's a high collinearity of some variables. The ones with the dark green shows us just the correlation within the variable, and the ones with the lighter green is now shows us the positive correlation, and the ones in blue is what shows us the negative correlation. So there's a presence of multicollinearity, and what happens with multicollinearity, when we have multicollinearity means that some variables might not be useful to us. So that brings redundancy between variables, given that there is a dependency. So from there, we also we did a comparative analysis in terms of models, and we ran for the nearest neighbors models and also compared the tree models. And from our models, we see that the nearest KNN1 performed better compared to other, compared to other models. And this is true because KNN is usually tends to use we tend to look at the closest distance, and given that there's a good distribution and balance within the response variable, this is behavior that we expect from the KNN models. And KN11 will perform better than any other. So also something to note about KNN1, it's also being affected by the fact it overfits because it uses the smallest distance that it can find within the data point. So that's all. Also, we try to check on the performance of the decision tree, and something you can notice, the higher the number of the decision points that we are making, we realize the the model starts get better. So we also tend to avoid overfitting at this point. And I think that's all from the the data set. And one thing that you can learn, that when you are creating your model, you need to know that you need to know the relations that are within the response variables and the predictors. And through this, in our model, we've tested this using the Cruz-Wallis test, and also we've used the boxplot to help us understand our variables better. Thank you.